I'm Dawn Dodge, and I am coming to you from quarantine. So if you hear some children in the background or maybe some dogs barking, I apologize profusely for that. So I'm going to be doing a presentation on groundwater pollution. This is for the Environmental and Society class. My name is Dawn Dodge, and my report for the mid-semester presentation is on groundwater pollution. How does groundwater become polluted or contaminated in the first place? Well, groundwater pollution occurs as a result of a release of pollutants into the natural underground reservoirs or aquifers. Once these pollutants make their way into groundwater, they cause contamination of that specific resource. While pollution is caused naturally, generally it's caused by the release of substances either intentionally or accidentally released through humanity's interaction with the environment. So there are a lot of causes of groundwater pollution. I could spend all day going over them. There's literally hundreds, but we're going to go over a few of the main reasons for groundwater pollution. So there are natural causes. There are septic systems, hazardous waste, petroleum product waste, solid waste, agricultural chemicals, surface impoundments, injection wells, and other pollutants. And we'll go over a few of these in more detail through the slides. So what are some natural contamination causes? Naturally occurring pollution can be caused by substances in the soil or rocks. They contain things like sulfates, fluorides, and arsenic. You can read further on the slide. Decaying organic matter moving in groundwater as particles can also be a source of pollution. In excess, these particles can contaminate groundwater to the point that it needs to be treated prior to drinking, or even it can be made untreatable. Naturally occurring pollution can be further exacerbated by over-pumping from the source. So this is the case in California's San Joaquin Valley. When they're pumping water profusely out of the aquifer, this causes the water table to go down. And as it goes down, the soils and the gravel all kind of like squeeze together like a sponge. And in the clay, there is arsenic, and that gets put more into the aquifer. So as the ground settles, because the water table goes down, it squeezes out more arsenic, which ends up in the aquifer. So it further pollutes the water just because we're using too much of it. Groundwater pollution by septic systems. So a major source of groundwater pollution in the United States is because approximately 1/4 of households in the US use these systems to dispose of their human waste. Even though each individual system releases like a small amount of waste, all those systems together, because there's a large number of them and they're widely used, makes them a serious contamination issue. Septic systems that are improperly sited or designed or constructed can contaminate groundwater with bacteria, viruses, detergent, oils, basically anything that you put down your sink. If those septic systems aren't in good working order, they end up in our groundwater. Additional cleaners, like when you flush those maintenance packets down the toilet and it ends up in your system, they further contaminate the water supply as well, and they interfere with the natural decomp process. Because these are well-known risks, most states and local regulations require specific separation distances between septic systems. So they require you, and you have to get a permit, to dig a well a certain amount of feet away from the septic system. So this has become more regulated over the years. I know in Vermont, I think it was about 5 years ago, the state actually started mandating that you had to apply for a permit to put in a septic system. Groundwater pollution by hazardous waste. So hazardous waste is defined as pretty much anything that can hurt human health or the environment. It's considered a hazardous. In 1976, the Resource Conservation and Recovery Act came out, which basically established a setup framework for the proper management and disposal of hazardous waste. While only one facet of hazardous waste is household related, it's estimated that in the United States, 1.6 million tons of household hazardous waste ends up in landfills annually. Not all of these substances are disposed of properly, and they end up in the landfills, adding to the groundwater pollution. Another impact of improper disposal of these hazardous wastes is the human toll. So it's an external cost. Sanitation workers suffer from the most injuries related to the improper disposal of these waste materials. They end up crushing these materials, or these materials are getting mixed and they're getting injured. You can learn more about hazardous waste and how to properly dispose of it at this EPA website. You can find the specific link here in my attached PowerPoint. Groundwater pollution by petroleum products. So underground and above ground storage tanks are commonly used to store petroleum products and other chemical substances. These include things like your underground heating tank, so it holds oil. Many businesses and organizations store gasoline, diesel, fuel oil, or other chemicals on site. They use these during the chemical industrial process or to store the waste for pickup by a licensed hauler later. It's estimated by the EPA that approximately 4 million underground storage tanks exist in the United States alone. And this poses a serious environmental threat to the groundwater pollution should these storage vessels fail. It's not just the storage of these products that is concerned. The EPA also estimates that approximately 16,000 chemical spill occur annually from trucks, trains, and storage tanks. This is just during the transferring process. And at those spill sites, those chemicals are just diluted with water and then washed into the soil, which increases the possibility for groundwater contamination. Solid waste disposal. So solid waste is disposed of in thousands of municipal and industrial landfills throughout our country. Chemicals that should be disposed of in hazardous waste facilities often end up in these landfills instead. The problem is also compounded because the disposal of those many household wastes that we talked about earlier, they're not regulated. Newer landfills are regulated more than previous ones of the past. They have to now meet certainly new imposed requirements to slow the pollution process, such as synthetic liners or clay covers and collection systems. However, we should note that previous landfills were not capped properly and continue to pollute our groundwater to this day. According again to the EPA, as of March 2020, there were currently 564 operational landfills in the United States and 480 candidate locations. So those are 480 sites that are slated for future use. This map shows all the documented open and closed landfills within the United States. Those in red are currently open and operating under current regulation. Those in green are closed and may have been operating under today's standards, but likely were not. So those are very serious sites for potential pollution. Groundwater pollution and agricultural chemicals. So millions of tons of fertilizers and pesticides are used annually in the United States for crop production. So in addition to farmers, there's homeowners, businesses, utilities, homeowners, these chemicals that all use these chemicals. These pesticides and fertilizers, some of them very toxic, have already entered and contaminated groundwater, and even when they're used appropriately. Some pesticides stay in the soil for months and possibly years. And animal waste is another agricultural source of groundwater contaminations. These contaminants enter the groundwater by seeping into the soil and through runoff. We learned about this predicament earlier in the year when we talked about CAFOs. Though the agricultural problem is not limited to large-scale operations, there are many family farms that contribute to this problem right here in Vermont. Groundwater pollution is a significant worldwide issue. Every day, 2 million tons of sewage and industrial agricultural waste are discharged into the world's water. So these are a bunch of statistics that I found through some easy resources. The UN, WHO, the World Health Organization, and UNICEF. The UN estimates that the amount of wastewater produced annually is about 15 km, 6 times more water than exists in all the rivers of the world. Lack of adequate sanitation contaminates watercourses worldwide and is one of the most significant forms of water pollution. 2.5 billion people live without improved sanitation. Unsafe water causes 4 billion cases of diarrhea each year and can result in 2.2 million deaths, mostly of the children under 5. This means that 50% of child deaths each year are attributed to diarrhea and poor drinking water supplies. Even drinking water quality in developed countries is not assured. So in France, drinking water testing uncovered that 3 million people were drinking water whose quality did not meet WHO standards. And 97% of groundwater samples did not meet the standards for nitrate in the same study. So that means that this is a worldwide crisis. So it's not just the pollution, our demand is also going up. Our demand withdrawals for water in each country. Here's a map displaying the amounts per capita that we're using and we're consuming and that we're pumping out of the ground each year. As you can see, the United States is pretty high. Summing it up. So contamination of groundwater can result in poor drinking water quality, loss of water supply, degraded surface water systems, high cleanup costs, high costs for alternative water supplies, and significant health problems. In terms of water supply, groundwater contamination can be so severe that water supply must be abandoned as a source of drinking water. This is a problem especially in devastating areas already with insecure water supplies. As we have come to learn throughout the year, those who suffer the most are those at the bottom of the economic ladder. And where there's nowhere more true in this case than with the ability to get clean drinking water supply. In other cases, the groundwater can be cleaned up and used again, though this is very costly. Follow-up water quality must be monitored and often required many years. Because groundwater generally moves slowly, contamination often remains undetected for long periods of time. This makes cleanup of contaminated water supply difficult, if not impossible. If the cleanup is undertaken, it can cost thousands to millions of dollars. So how do we do better? Well, things that we can do at home, we can properly dispose of our waste, meaning don't dump chemicals down our drains or into our septic systems or into the sewer system. Test underground fuel tanks, make sure that all of our systems are operating properly. Safely store all chemicals and fuel. Minimize the use of chemicals. Use more green alternatives. Have an on-site septic system pumped and inspected every 5 years. Maintain those systems properly. Examine on-site wells and surrounding land areas and test wells often as pollution risk demands. Things we can do at work. Waste disposal. Proper disposal of all waste. Ensure that waste is going where it needs to go. And water discharge connections are properly used. Maintain on-site septic systems. Plug and cover waste dumpsters. Hazardous materials. We need to safely store and handle and use chemicals and fuels. Monitor any underground fuel and chemical tanks. Contain storage and loading areas and reduced or substitute use of chemicals. So we can substitute more pollutants for something that's a little greener. Stormwater. So keep chemicals and waste safe from rain and washing out areas. Isolate drains from storage and loading areas and use specific solvents. Use pesticides sparingly. How can we do better in town and legislation? Well, we can ensure that the land use plans and regulations protect important water supply aquifers as well as fields. So we don't want that runoff going into fields. Support protection legislation and programs. Inform and educate residents and businesses about groundwater protections. Make sure to get that information out there. Consider important aquifers when acquiring open space. Conduct household hazardous waste collections. So that's important. We have that here in Vermont. We have funds and we have awareness around it. We have annual drops-offs at our local dumps to make sure that these hazardous household wastes are going where they need to go. Ensure that town departments practice good pollution prevention. And here are my citations. You can see a follow-up in the complete PowerPoint presentation, which is also attached to this video. Thank you so much, and you guys have a great day.